Hello everyone. Today I will be showcasing a project that I've been working on for a while. So I basically built a real-time dog posture detection pipeline that uses AI. Well, I first used a YOLO model to detect if there is an AI in the picture, and then that model sends the picture to another YOLO model, but that model is for pose estimation, and it basically puts key points on the different joints on the dog, and then I extract features like the angles between the joints and the distances between the joints. I extract those features and I shove them into my third machine learning classifier model. And that model basically detects if the dog is sitting, standing, or laying down based on the features that I gave it. Now, at first, I tried using just one model to do all three tasks, and it didn't really work because it didn't really scale well. If there's different lighting, if it was a different angle, it wouldn't be so accurate. So I opted for the 3 AI model design, and that allowed it to scale a lot better. And I now normalize the key points, and it's invariant to the size of the dog or the position of the dog or the angle. So that's basically it. One of the problems I actually had was the key points were very jittery because I'm using the smallest AI models. Because ideally, I want this to be able to run on edge devices. So I want to like be able to put this on a robot where there isn't as much processing power as a computer, right? So I'm using very small AI models. So I have to be very efficient about the way I go with like choosing my data and processing my data. So the key point model, the pose estimator model, the key points were very jittery from frame to frame. So it wasn't really giving me accurate calculations and it was messing everything up. So what I ended up doing is frame smoothing. And let me see if I can find it here. I can't find the line of code, but frame smoothing is basically I look at two frames and look at the key point in each frame. So let's say the key point of the nose. So in this frame it was here, in the other frame it moved right here. So I would take the average. That way it smooths it out, and it gives me more accurate results. But yeah, let's just get straight into the demo. I need to call my dog over. I'll just give me a second to set this up. Okay, if we look here, I'm not sure if I can make this bigger. I can't make it bigger. But if we look here, it is correctly classifying my dog as lying down. I'm going to try to get closer to the mic. But let's see. Cindy, can you sit, please? I hope she sits. Please sit. See, now it's detecting that it's sitting, and now it is standing. So that is basically the gist of the model. And come back. I'll pause this real quick and I will be back again. Okay, I'm back here now. Sorry, I only have one camera. That's why I had to finagle it around. But yeah, as you can see, that was a very short demo. And the model, don't get me wrong, there is a lot of room for improvement, but I just wanted to showcase a big demo, or sorry, I mean a small demo. What I would improve, maybe I would add a lot more data for my classifier model, because for that model I only used 1,000 photos. When we compare that to the dog detector model, I used 6,000 photos that I personally labeled, and for the key point model, the pose estimator model, I used 19,000 photos, and it was actually a data set that I found online that was already labeled with the key points. It was just ready to train an AI on, which was great. But yeah, one of the issues that I already talked about was the frame smoothing. I figured that one out. Another one was I wasn't getting the results were not very accurate, so I ended up doing something a little smart right here, which is this. This is basically a majority vote system. So if the classifier models classifies the dog as sitting and then sitting and then sitting and then standing and then standing within a small amount of time, like a second, right? It does a majority vote system where, oh, there's 3 sitting classifications and then just 2 standing classifications. 3 is more than 2, then classify it as sitting rather than standing. So that actually helped a lot. But yeah, that's basically the gist of it. I will be doing a full code analysis video, but that video will be aimed towards a more technical crowd. So if you're interested in that, stay tuned. It'll be the next video. I will also leave a link in the description for the GitHub page for this AI posture detector if you want to download it and play around with it yourselves. But yeah, that was everything. Thank you for watching, and I'll see you in the next one.